Good afternoon to all the learners, faculty members and distinguished guests. On behalf of the Department of Earth and Environmental Science, we welcome you all to today's live teleconference. Topic is on Karst topography and glacial topography. These two topographies are very fascinating landscapes in the physical geography. To discuss depositional landforms and erosional landforms and beautiful landscapes which are formed by this action of water and glaciers, we will discuss today. To discuss and enlighten us on these two topics, we have distinguished academicians. We have two academicians. One is our first resource person is Dr. Vigneshwar Mekha. He is working as assistant professor and head Department of Geography in Government Degree and PG College for Women, Autonomous Begumpet. Sir has more than 20 years of teaching experience in geography. He also published more than 10 national and international research papers in various journals related to geography, environment and climate change. Sir authored more than 14 books in the Department of Geography and which is useful for environmental students also. Welcome sir, welcome to the studio.
Welcome.
And this lecture. And another resource person, Dr. G. Ambedkar, Assistant Professor, Department of Earth and Environment Science, Dr. B.R. Ambedkar Open University. He has more than 5 years of teaching experience in geography subject. Welcome sir, welcome to today's seminar, to the teleconference. We are honored to have both these eminent scholars with us today. On behalf of Dr. B.R. Ambedkar Open University, I extend a heartily welcome to Dr. Vigneshwar Mekha and Dr. G. Ambedkar. Without further delay, I request our esteemed resource person Dr. Vigneshwar Mekha to explain all these features of this Karst topography and glacial topography. Thank you sir, welcome.
Thank you Subhash garu and Ambedkar garu. And I welcome you all to the learners for this teleconference. BA Geography, first semester, the fundamentals of geomorphology. In this lesson, we are going to discuss about Karst topography and glacial topography. To begin with this lesson, we will start the objectives of the lessons. After the end of this lesson, you all will be able to learn what are the conditions for the formation of the Karst topography and glacial topography. Thereby, you will be able to understand how the erosional and transportation processes are formed by the various processes going on. And also, you will learn the formation of the landforms made by depositional landforms made by the groundwater as well as the glacials. To begin with the introduction to Karst topography. The word Karst actually is derived from a region known as Karst from the Balkan region, which is at the coast of the Adriatic Sea belonging to the Slovenia, the erstwhile Slovakia. So, this region was first studied regarding the Karst landforms, where the scientists have first identified and studied the Karst landforms which are made by the underground water action. The Karst topography especially deals with the landforms created in the limestone areas, dolomite areas or the gypsum areas where the groundwater action is more on these specified rocks by solution as well as the deposition in terms of the solidification. To study this Karst topography, the conditions for the formation of the Karst topography includes the region where the Karst landforms are formed, that should be a large stretch where the rocks are soluble, which allows to penetrate water inside. And the second is limestone should not more porous, but they should allow the water to pass over them, and the rock should be more denser but thinly bedded over the surface, and there should be joints in these rocks, and there should be the permanent source of water which is naturally perennial, where the water flow allows the formation of the karst features. In order to form these karst landforms, moderate to abundant waterfall also needed, so that the solvent action of the water, that is the solution of the rocks, takes place. You all know that when the rain occurs or snowfall takes place, water flows onto the surface as a runoff, thereafter it sinks into the soil. As the water becomes contact with the carbon dioxide in the atmosphere, it becomes as a acid, that is acid rain, and which chemically dissolves the limestone deposits or dolomite deposits on the surface of the earth. As the rainwater moves down into the surface through the fractures, through the joints, through the spaces, and these water dissolves the limestone and dolomite rocks. The karst topography formation generally depends upon the different kinds of landscape rocks. So, the main rocks that are involved in the karst topography are limestone and dolomite. Limestone is mainly composed of the calcite, which is soluble in nature. The dolomite is also similar to the limestone, but contains magnesium in addition to the limestone minerals. So, these both rocks are soluble in water when they are contacted with the acid or general water. When the groundwater moves on in the limestone areas or the dolomite areas, there we observe three kinds of the actions. Those are called underground water actions or karst actions. They are namely, number 1, erosion, number 2, transportation, and number 3, deposition. Erosion: when the underground water moves through giants, fractures, or through the limestone areas, this water erodes the landscape primarily through the chemical process called the carbonization or the solution, rather than the physical abrasion process. So, these soluted calcium carbonate has been carried out by the groundwater through the surface, through the giants and fractures. At times it is underground water. So, those surface rivers which transport large sediments via physical force, groundwater predominantly transport its loads as dissolved load, which is called the karst load or underground water load. It generally comprises of calcium carbonate in more. As soon as these underground water reaches the surfaces, when they cross the joints and fracture them, when they overwhelm on the surface of the earth, when they reaches the roofs of the caves or caverns lying under the surface of the earth, slowly deposition occurs because water droplets are dropping from the roofs of the caves, and when the air pressure or air touches these calcium carbonate, slowly the water is evaporated, the calcium carbonate is solidified on the roof of the caves. At times it falls onto the ground or the floor of the caves, then they start to solidify in terms of the rocks. We call them as deposition or sedimentation, and this deposition process said to be the solidification. If you observe the process of the groundwater erosion on the limestones, generally when the rainwater in contact with the carbon dioxide in the atmosphere, it becomes as an acid, calcium carbonate. Rocks are dissolved, soluted, and thereby they are moved along the ground pathway of the groundwater at the surface water. When the groundwater moves on through the joints, fractures, at times they reaches the slopes of the mountains and roofs of the caves. Then the in due course of the solution, the groundwater creates various landforms. Those landforms are said to be the karst erosional landforms or erosional landforms made by the karst topography. So, those landforms generally found on the surface, even at the caves and below the surface, and the surface land features that are generally observed in the karst areas are limestone pavement, clins and grikes and carens, etc. Where the surface is rugged, bed with the limestone, with flat surface shaped by the carbonation along bedded joints, a textbook karst structures or signatures are formed, which we call them as the limestone pavement. We also find some kind of the clins and grikes. The flat blocked rocks found by the groundwater erosions are called clins, and deep fissures that are found, the crack like structure that are found in the limestone areas are called as the grikes. At times, the small scale dissolution also takes place when the weak minerals lie in the limestone areas. They have been grooved in floods on the limestone surface. Then we see a kind of the small depressions found on the limestone surface. We call it as the carens. At times, when the groundwater dissolves huge amount of the limestone or dolomite or gypsum in its pathway, deep holes are created, depressions are created, and they are more susceptible to the solution weathering because of the groundwater. When these minerals are dissolved, limestones are dissolved, deep and vertical depressions are formed, which we call them as the sinkholes. Sinkholes. So, there we see more sinkholes in the Kentucky region of the United States of America, which are approximately 5.4 sinkholes per every square kilometer, and that area is about 153 square kilometer area, and there we have 826 surface depressions, that is sinkholes, we see within this 153 square kilometer area. When these dolines are formed in the form of cylindrical shape underneath the surface, they are almost similar to that sinkholes. We call them as the swallow holes. Swallow holes. So, when the swallow holes, number of swallow holes collapse with each other, there we see a large halo which is formed vertical and deep sided depression. We call it as a dolines. Dolines. Okay. Here the dolines are larger than the swallow holes. When the several dolines may merge as a result of the subsidence, the nearby dolines are collapsed because of the subsidence of their lateral sides, and there we see a huge or the larger depression, which we call it as a uvula. In the same way, when two side by side uvulas are collapsed, or thereby the subsidence of their walls, there it forms a huge vast depression that is said to be a polge. So, generally polges are occupying or extending about 100 square miles, but produced partly due to the faulting actions, that is the subsidence of the sides of the uvulas or dolines, etc. In due course of the groundwater erosion, below the surface there we have huge amount of the limestone areas. When this groundwater flows slowly, the limestone are dissolved and soluted and carried by the groundwater, and there we see a tunnel-like shapes. And these tunnel-like shapes at times are called as natural tunnels, and at times these roofs of these natural tunnels are collapsed because of the groundwater erosion. So, when we look at the collapsed part, from the collapsed part inside this tunnel, there we see the movement of the groundwater. Such type of the substratum, subterranean rivers are said to be the karst windows. Karst windows. At times we also observe the deep caves inside the subsurface, below the surface of the earth. They stand as a remnants of the cave roofs, and they have otherwise eroded away dramatic monuments to persistence of the dissolution. When the collapse of these caves occurs and smaller portion of the cave's roof remains the same, and which looks like a bridge, are called natural bridges. When the huge amount of the limestone below the surface has been eroded, dissolved, soluted and carried in the form of calcium carbonate by the internal streams or substratum streams, and there we see the type of caves or caverns. As these groundwater carrying away the calcium carbonate, slowly this water reaches upper surface of the earth. When they reaches the top roof of the caves, and the water slowly comes onto the surface, the floor of the cave in the form of the water droplets. Or at times when this groundwater upwells from the fractures, joints or cracks of the rocks, it slowly moves from the cracks downward. At times this water also reaches the surface of the earth when the groundwater approaches the slope of the mountain or slope of the plateau or slope of the total local terrain. Then the calcium carbonate, which is formed by the solution of the limestone, slowly solidifies on the surface of the earth or floor of the caves, or solidifies in between the cracks or joints of the rocks lying on the surface of the earth. And this process is called the deposition of the karst action or the groundwater. Thereby we see formation of various karst depositional landforms. Now let us discuss about the karst depositional landforms. When the groundwater slowly leaks from the roof of the cave, there we see dropping of the water from the ceiling of these caves. While it is falling onto the floor of the cave, the waters are evaporated with the friction of the air or the wind, and the calcium carbonate is solidified and hanging to the roof of the caves. Slowly the solidification becomes larger and it hangs to the roofs of the caves. And such depositional features which are formed by the solidification of calcium carbonate are beautifully forms as a stalactites, which are hanging on the roof of the caves. When the water is dropping from the roofs of the caves, at times when the wind is not blowing into the cave, the water falls onto the floor. After falling onto the floor, water sinks inside and the calcium carbonate solidifies on the floor of the cave. Slowly that solidification rises upward, and which is said to be as the stalagmites. And these stalactites grow on upward and stalagmite grow on downward. When the both stalactites and the stalagmites join together after gradual growing, they form a columnar shape. As the process grows, both stalactite and stalagmite often join together to form a vertical column or vertical pillar in the caves or in the caverns are called the pillars or columnar forms, columnar landforms. We generally see such type of the stalactites, stalagmites and columnar features in Borra caves of Araku Valley region in Andhra Pradesh state. Thereafter, as the groundwater moves in its pathway, the calcium carbonate or the calcareous deposits form dripping of water in dry caves where the water is very fever, and these are called dripstones. Dripstone, they are smaller than the stalactites. Besides this, all types of deposits in the caverns are collectively called speleothems, of which calcite is common constituent that is found from the limestone or the dolomite minerals. Besides the dripstones, we also see drape-like features. Numerous needle-like shaped dripstones hanging from the cave ceiling are called drapes or curtains, which are smaller than the dripstones are smaller than the stalactites. These features are mainly found in the underground caves or caverns which are created by the karst action, that is the groundwater erosion. But the process involves here is the solidification of the calcium carbonate, that is the calcareous deposits. Apart from this, we also the flow stones, where the floor deposits caused by the seepage of water, and that water flowing out of the stalactites are called flow stones, which looks like a moving water, but the calcium carbonate is solidified while the water is moving in the caves. The similar structures also found in the caves, travertines and tufa or other forms. The banded calcareous deposits are called the travertines, whereas the calcareous deposits softer than the travertines at the mouth of the caves are called tufa or calcite tufa, calx tufa, or the other names given to this tufa. So these are the important landforms made by the karst action, both by erosional and depositional action.
Thank you, sir. Thank you, sir. Thank you for explaining karst topography. For the convenience of Telugu medium learners, Dr. G. Ambedkar sir will explain the same thing in the Telugu medium.
ఓకే, థ్యాంక్ యూ డియర్ సుభాష్ గారు. భూస్వరూపాల గురించి మనం ఇప్పుడు తెలుసుకోబోతున్నాం. భూస్వరూపాలు అంటే సున్నపు రాతి మీద వర్షం నీరు పడి సున్నపు రాయి కరిగిపోయి భూస్వరూపాలు ఏర్పడతాయి. ప్రధానంగా భూస్వరూపాలు 3 విధాలుగా మనం తెలుసుకోవచ్చును. సింక్ హోల్స్, డోలైన్స్, హుహాలా. అయితే సింక్ హోల్స్ గురించి మనం తెలుసుకుందాం. సున్నపు రాయి ఎప్పుడైతే కరిగిపోయి భూస్వరూపం ఏర్పడుతుందో అక్కడ చిన్నగా క్రమంగా ఒక చిన్న హోల్ పడుతూ ఉంది. దాన్నే సింక్ హోల్స్ అంటారు. ఆ చిన్న హోల్సే పెద్దగా కానీ డొలైన్స్ అంటారు. పెద్ద హోలు ఇంకా పెద్దగా గుహలకు ఏర్పడేదాన్ని ఊహాల అంటారు. దీన్ని ఫర్ ఎగ్జాంపుల్గా మనం విశాఖపట్నంలో ఉన్నటువంటి బొర్రా కేవ్స్ని మనం చూసుకోవచ్చు. ఈ బొర్రా కేవ్స్ చూసినట్లయితే అక్కడ మనకు స్టాలక్టైట్ అని ఏర్పడుతుంది. స్టాలక్టైట్ అంటే ఈ ఉపరితలంలో ఉన్నటువంటి సున్నపురాయి చిన్నగా దారగా కింద పడుతూ పైనుండి కిందికి ఏలాడపడుతూ ఉంటుంది. దీన్ని స్టాలక్టైట్ అంటారు. అదేవిధంగా స్టాలక్మైట్ అంటే కింద నుండి పడిన తర్వాత కింద నుండి కూడా పైకి వచ్చేదాన్ని స్టాలక్మైట్ అంటారు దాన్ని. సో ఈ స్టాలక్టైట్, స్టాలక్మైట్ ఈ 2 కలయికనే పిల్లర్గా అంటారు. ఈ 3 అంశాలు కూడా మనకు బొర్రా కేవ్స్లో చాలా స్పష్టంగా మనకు కనిపిస్తూ ఉంది. అదేవిధంగా ఈ యొక్క భూస్వరూపాలు.
థ్యాంక్ యూ సార్.
ఓకే,
నాకు చిన్న డౌట్ సార్. బెనిఫిట్ ఆఫ్ లెర్నర్ సార్, మన తెలంగాణలో ఈ కర్స్ట్ టోపోగ్రఫీ ఎక్కడైనా ఉందా సార్?
ఇది తెలంగాణలో ప్రధానంగా జయశంకర్ డిస్టిక్లో ఉందండి. ఇది ప్రస్తుతం వరకైతే ఒక 10 గుహలను గుర్తించడం జరిగింది రాష్ట్ర ప్రభుత్వం. ఈ యొక్క ప్రాంతాన్ని మనం ఒక పర్యావరణంగా ప్రదేశంగా తీర్చిదిద్దినట్లయితే ఎందరికో అక్కడ ఉన్నటువంటి గుహల గురించి ఇంకెక్కువగా తెలుసుకోవడం విస్తృతంగా ప్రచారంలోకి వస్తుంది. దాన్ని బట్టి అక్కడ ఉన్నటువంటి భూహంతర భాగంలో ఉన్నటువంటి గుహలు మనం వెలకి తీసిన వాళ్ళం కూడా అవుతాం.
ఓకే సార్, మై క్వశ్చన్ ఈస్ టు డాక్టర్ విఘ్నేశ్వర్ మేక సార్. Sir, how to identify stalactite and stalagmite, sir? How to differentiate both? What is how based on the shape or how?
Yeah, it is very easy to identify the stalactites and stalagmite. The stalactites are the solidified calcium carbonate, which is generally hanging on the roof from the ceiling of the caves. They are like ఊడలు, మర్రి చెట్టు ఊడలు. ఓకే, ఊడశిలలు ఆల్సో వీ కాల్ ఇన్ తెలుగు. స్టాలక్టైట్స్. ద స్టాలగ్మైట్స్ ఆర్ వర్టికలీ గ్రోయింగ్ ఆన్ ద ఫ్లోర్ ఆఫ్ ది కేవ్. పుట్టలాగా డెవలప్ అవుతూ ఉంటాయి, పుట్టశిలలు అని చెప్పేసి కూడా మనం పిలుస్తూ ఉంటాం. ద హ్యాంగింగ్ ఆన్ ద సీలింగ్ ఆఫ్ ది కేవ్స్ ఆర్ స్టాలగ్మైట్స్ అండ్ రైజింగ్ యాజ్ ది pillars like structures on the floor of the caves are the stalagmites.
Thank you, sir. Thank you for clarifying this. So, ఊడల్లాగా ఉండేటి స్టాల్కటైట్స్ అండ్ పుట్టలాగా పెరిగేటి స్టాల్గమైట్స్. ఓకే, అవి రెండు కలిసిన తర్వాత ఏర్పడి ద పిల్లర్ ఆర్ కాలమ్. థ్యాంక్ యూ సార్, థ్యాంక్ యూ ఫర్ క్లారిఫైయింగ్ దిస్. అండ్ వాట్ ఈస్ ద డిఫరెన్స్ బిట్వీన్ ద సింక్ హోల్ అండ్ డోలైన్, సార్?
Sinkholes are smaller. Sorry. Sinkholes are smaller in size. Dolines are larger because when the two side by side sinkholes are collapsed, forms the huge depression which we call it as a doline.
Thank you, sir. Thank you for clarifying this. In Karst topography, Karst actions, erosional landforms and depositional landforms. Sir explained very beautifully with these slides and all. And in Telangana also we have Karst topography. Dr. Ambedkar sir explained about it. In Bhupalpalli, Jayashankar district, we have Mailaram cave, Nallagutalu, where we have more than 10 caves, which are result of this water action on limestones. And these caves can be useful for tourism encouragement and development. Thank you, sir. Thank you very much. And Dr. Vigneshwar Mekha sir will continue with the glacial topography. Thank you, sir.
Welcome. Dear learners, so far we have focused on the karst topography. Now, let us look into the glacial topography. We all know that water remains in 3 states. One is liquid condition, water. Another one is solid condition, ice. And third one is gaseous condition, that is vapor. This water, when reaches low temperatures, the water converts into liquid, so solid, that is called ice. We all know that when the temperature in the atmosphere is changing, the water vapor in the atmosphere slowly condenses, thereby it converts into solid flakes, which we call them as the snowflakes. When the snowflakes, the solidified water vapor reaches the surface of the earth, we call it as the snowfall. The continuous snowfall on the surface, when these snowflakes are accumulated on the surface of the earth over the time, they solidify as a rock, which we call it as a firn. These fins, after formation of the layer by layer, the frictional force and the gravity of the earth, these ice crystals, the ice is moving along the slopes of the mountain very slowly. This moving ice is called ice river, also known as the glaciers. In today's chapter, we discuss about what is glacier, what are the types of the glaciers, what kind of actions we see by the glacial actions. As we discussed in the Karst topography, in this lesson also we have few objectives. After end of this lesson, you will be able to understand the formation and movement of the various glaciers, and we can understand the various types of the glaciers, and we also understood how the glaciers erode the land, transport the debris material and deposit on the surface of the earth, and consequent land features formed by the glacial erosion and glacial deposition. Begin with, we look into the formation of the glaciers. Moving ice is called a glacier. To form a glacier, there we need certain conditions, the prerequisites. They are: number 1, cold local climate. We are all aware of that. If one moves from equator to the poles, the polar latitudes are the high elevated regions are experiencing low temperature, where the water vapor in the atmosphere condenses and freezes, thereby the water vapor forms as a snowfall onto the surface. This abundant snowfall on the surface must be abundant. More snow must fall than it melts, and then it keeps on moving at times as a reverse, but most of the time this solidified ice moves in the solid form only, and those we call the glaciers. As the snowfall occurs in high elevated areas or in the polar latitudes, the snow must not be removed by avalanches or the winds or by the melting of the ice by the temperatures. In such conditions, we see the formation of the glaciers in the high altitudes, in high elevated areas above the snow line. In Himalayas also we see the various glacials, so that we call the mountains as the Himalayas, the abode of snow. Himalayas. You all know that the snowflakes are solidifying by the accumulation, by the film formation as the glacial ice. When these glaciers undergo the gravity of the earth, they slowly move along the slopes of the mountain valleys, and the moving ice is said to be the glaciers. Now, let us discuss about the classification of glaciers or the types of glaciers. On the basis of location, glaciers can be classified as the following 4 types, namely the continental glaciers, the ice caps, Piedmont glaciers and valley glaciers, also known as the mountain glaciers. First, we may with the continental glaciers. The largest types of glaciers on the earth are the continental glaciers. They cover large areas of the land surface, including mountain areas also. So, modern ice sheets over Greenland and Antarctica continents are the continental glaciers. These 2 ice sheets comprise about 95% of the glacial ice currently available on the surface of the earth. So, the best examples of the continental glaciers are Lumpet and Beardmore. And the second is the ice shelves, are also called the ice caps. Ice shelves or ice caps are of sheets ice floating on water attached to the land. They usually occupy coastal embayments, may extend hundreds of kilometers from the land and reach thickness of 1000 meters at an average. Generally, we see these kind of glaciers where the the mountains and the oceans are very close in the polar latitudes. Another type is the Piedmont glaciers. These glaciers, by name itself, appear on the foothills of the mountains, so that we call them as Piedmont glaciers. So, they spread onto the fan or bulb shapes along the slopes of the mountains. For example, to say the Malaspina glacier in Alaska is the largest Piedmont glacier in the world. And the fourth one is valley glaciers. They are also known as the mountain glaciers and first studied on alpine mountains, so that we call them as the alpine glaciers also. So, these glaciers are predominantly found on the alpine mountains, Himalayan mountains, Andes mountains, even Rocky mountains. The highest mountains across the world comprises of these valley or mountain or alpine mountains. The largest of Indian glaciers occur in Karakoram ranges are the Siachen glacier, which is about 72 kilometers long. Apart from this, we have Gangotri glacier in Uttar Pradesh, which is a source of origin of river Ganga, etc. Like the groundwater performs three kinds of actions in the limestone areas, glacials also perform three types of actions on the mountain slopes, also along the coastal areas. And these actions are namely, number 1, glacial erosion, number 2, glacial transportation, number 3, glacial deposition. The process by which the moving mass of ice carve and wear away and reshape the surface of the area from where the glacier is moving, and that is said to be the glacial erosion. Glaciers are incredibly more powerful agent of erosion than the other kind of the natural agents. Glacials perform erosion process in two ways. Number 1, plucking, number 2, abrasion. We will discuss about these processes in the later sections. The second is glacial transportation. When the glacials erode the land, the pebbles, debris, gravels are carried by the glacials and in the mountain valleys, and these pebbles, gravels and rock particles, rock debris carried by the glaciers are said to be the glacial load. The glacial transport the glacial load in three ways. They are supraglacial, which carried by glacier on its surface, englacial, carried within the glacial, subglacial, which is carried under the glacial. Finally, this glacial load is deposited somewhere, which is called as till. When the till is deposited in a huge amount in the pathway, the kinds of moraines are also formed. We will discuss them in the later session. That process is called the glacial deposition. Now, let us see the plucking process, that is a kind of erosion of the glacier. Plucking is also called quarrying, the most dramatic glacial erosion process that occurs in the glacial topography, that is in mountain areas. During the night, when the ice melts into water, reaches drains, fractures and smaller burrows formed by the animals. As the night reaches, the temperature decreases and the water transforms into the ice, that means solidifies. As it solidifies, its size expands about 10%, then the cracks, joints and burrows are collapsed, and this is called the plucking. Another erosion process of the glacier is abrasion. It works as a gained sandpaper. So while plucking tears rock away in the chunks, abrasion works more subtly, but with equally profound results are observed, that is a plucking and abrasion. Rock fragments embedded in the base and sides of the glacier valley act like sandpaper, which grinds against the valley floors, walls, and ice is removed and moved forward by the moving glaciers. In due course of time, there we see the glacial floor forms like a smooth surface. The glacier floor, the relentless grinding produces an ultrafine powder known as glacial floor, which gives glacial meltwater its characteristics milky turquoise color. As this ice moving on the floor of the valleys, the long parallel stretch marks are observed, which are carved out by the moving ice on the bedrock of the glacial valleys, and these scratches that found in the valleys are called glacial striations. At times, when the glacier is rolled over the rocks instead of sliding or grooving or grinding, the abrasion smooths upstream side of the rock outcrops, while plucks creates a rough and steep downstream face, forming a distinctive asymmetrical hills which are formed as the Roche mountains. They resembles like the mountain of the sheep. When the glaciers are moving along the slopes of the mountains, a bowl-shaped depression formed near the mountain top.
Now we have a call from a journal. Hello.
Hello, sir. Good afternoon, sir.
Good afternoon.
Sir, why is glacial erosion considered as important geomorphic process? Can I repeat it?
Yes, good question.
Very good question. So, because water is in a solid way, solid form, liquid form, but here the glaciers are in solid form. The glaciers performs erosion. While they are in the form of the solid, they perform the erosion. When the ice is melted and at times combined by the water and the ice, both combinedly erodes the land surfaces which are in its pathway, that is in the valley. So, that is multiplied by then the rocks of the erosion by the rivers. Rivers only dissolve the minerals, weak minerals, but here the solid water, that is the glacier, plucks the smaller pebbles, rocks and also gravels. It picks up in its pathway. When the water reaches the burrows, when the water reaches the joints, when the water reaches the cracks of the rocks, when it is freezing during the night, when the temperature decreases, the water freezes and it becomes an ice. When the water freezes and transforms into the solid form, its size increases about 10%. 10% of the mass of increases when it converted from liquid to solid. So, then the rocks are, the cracks and the joints are expanded, and this kind of work cannot be done by the moving water. Of course, the erosion by the rivers is different way, but here the ice perfectly works in wearing down the degrading the taller land features. We all know that the Aravalli mountains, one of the oldest fold mountains of the world, once upon a time they were about 6,000 meters altitude from the surface. Because of this action, they have been degraded.
Sir, on behalf of learners, sir, I want to ask one more question, sir. Now and then, every day we are reading the newspapers that glaciers are melting.
Yes.
Is there any connection between the glacial melting and climate change, sir?
Exactly. We all are concerned about the global climatic changes. Because of the industrialization, industrial revolution, so much of pollutants are reaching the atmosphere, reaching the surface, reaching the water, and so on.
Hello?
Hello, sir.
Yes.
Good afternoon, tell me.
Good afternoon, sir. Active glaciers are absent in Telangana.
Okay.
Which climatic factors prevent this glacier formation in Telangana region, sir?
Okay. Okay, thank you. You want to ask that?
Yeah. So the glacier action is confined to the areas where the glaciers are existing. But here, no glaciers appear, no glacial erosions occur. But in Telangana region, the erosion is more predominantly by the wind action followed by the river action. There is no scope for the glacial erosion in Telangana region.
Sir, continuing to this question, sir, I have one more question, sir. Why should a person living in Hyderabad or Telangana should care about glaciers that are more than 2000 kilometers away from Telangana? That is mostly located in north,
Himalayan
that
region.
Himalayan region.
Yes.
The ocean, the glaciers presented there and melting happens there. But why should we fear?
Yes, because every day from the early morning to the late night, we used to take water in various forms for drinking, for taking bath, for agriculture, for washing clothes, for cleaning up the floor, etc. So, on the surface of the earth, the consumable water is very less. It is about 4% and below, out of which maximum is in the form of ice, that is in the glacier form, which lies on the tops of the mountains, which lies on the Antarctica continent and also in tundra region. These global climatic changes led by the global warming, they are causing for the melt of the ice. If the ice is completely melted and reaches to the oceans, and the sources for the formation of perennial rivers will disappear. We know in India we have two kinds of rivers, perennial rivers, non-perennial rivers. The peninsular rivers are non-perennial and the Himalayan rivers are perennial. If the ice is melted at a time, the whole water will reach to the oceans during the course, floods may occur, and after these, the ice is completely melt out and reaches the oceans, and there will be no source for the continuous flow of water even in the summer, and that leads to the drinking water scarcity not only in India but also across the world. So that we should be concerned, we should be scared of these glacier melting. So it is our everyone's responsibility to check the global warming, to check the climatic changes, which various policies are provided by the various government organizations, not only India but also in the world. Everyone should concern about the glacier melting.
Thank you, sir. Thank you very much. And I have one more doubt, sir, because most of the learners in this university are when they are studying geography and they are writing the exams, they are mostly confusing with the U-shaped valleys and V-shaped valleys. So,
okay,
U-shaped valleys and V-shaped valleys.
Yeah.
So
can
you
U-shaped
explain
valleys are concerned with this glacial erosion, whereas V-shaped valleys are with the fluvial topography. So of course, we will discuss about the U-shaped valleys in this session.
Okay.
V-shaped valleys, the name itself resembles that the valleys are vertical, V in shaped. When the running water erodes the land vertically, the valleys are narrower and their floor is very narrow, their valley is very less width. So they are mainly formed by the fluvial actions, that is reverse action. Whereas the U-shaped valleys, when the V-shaped valleys are formed by the rivers, these already existing V-shaped valleys, when they are undergo the action of the glaciers, when the glacier reaches through these U-shaped valleys, V-shaped valleys, V-shaped valleys become U-shaped. Floor will be
One more
broader
caller is
and
in line, sir.
right.
Hello. Hello.
Yes, Chapan.
Hello. చెప్పండి.
Sir, one question, sir.
చెప్పండి సార్.
How does glacial deposition differ from glacial erosion?
Glacier deposition is different from glacier erosion. Thank you.
Yeah, very simple. When glaciers remove the rocks, wear and tear the rocks, those eroded rock debris, the pieces of the rocks are carried by the glaciers and deposited somewhere. When the speed, the velocity or the movement of the glaciers is ceased, there the rocks which are being carried by the river on its surface or within the glaciers or base of the glaciers, and this eroded material is deposited at the valleys, the bottoms of the valleys. So erosion is a process, the removing of the rocks, and deposition is the process, the leaving of the sediments. So both are different.
Thank you, sir. Thank you very much for clarifying this doubt for the learner use. In this teleconference, sir has covered all the topics like Karst topography and glacier topography related issues, and the actions of Karst topography and the erosional landforms, depositional landforms of Karst topography, and as well as glacial topography. Sir also clarified how climate change is impacting glacial melting, and why we are concerned about glacier melting, because the most of the usable water is accumulated in the form of glaciers, which are melting rapidly because of the climate change. Thank you, sir. Thank you very much, sir. Thank you, Ambedkar sir, for clarified the doubt that is we have Karst topography in Telangana. Thank you, sir. And sir, I have one more.
Concluding this,
I have a doubt,
this
sir.
session. One telecaller's doubt is not completely cleared. I will
Okay.
let me complete that one.
Okay.
The V-shaped valleys. V-shaped valleys are formed by the river action, vertical action. So when the glaciers reaches the V-shaped valleys, or when these glaciers move along the slopes of the valleys of the mountains, the glaciers resemble the wider and deeper. So the V-shaped valleys cut down and form as a U-shaped valleys. They resemble the U letter, and these glacial erosion grinds the surface bottom of the valleys. Then the valleys become deeper and the floor is wider, then resemble the U-shaped valleys. The U-shaped valleys are formed by the glaciers, V-shaped valleys are formed by the rivers.
Hello.
Hello, sir.
Hello.
Sir, what role glacial deposits play in groundwater recharge and as well as river systems?
Okay. Thank you.
Yeah,
Sir will answer your answer.
very good question. Glaciers are the sources of the perennial rivers. Across the world, most of the maximum perennial rivers or permanent rivers are because of the melting of the glaciers only. So when these glaciers melted, the water slowly forms the rills, rill forms the streams, streams forms the rivers, smaller rivers, and when the both smaller rivers join together, larger river is formed. When this water moves along its pathway when they form in the mountains, they pass through the plateaus and thereby the plains. In their catchment area, the glaciers are indirectly contributing in the growth of groundwater table. Directly they do not contribute because in the mountain areas only the glaciers retain. As they melt and they move in the form of water, they do not take place directly. The water itself, the rivers itself increases, charges the groundwater in the aquifer area from where, in the catchment area from where the river is flowing.
థ్యాంక్ యూ సార్, థ్యాంక్ యూ ఫర్ క్లారిఫైయింగ్ దిస్ డౌట్. లెర్నర్స్ చాలా యాక్టివ్గా పార్టిసిపేట్ చేస్తున్నారు సార్. మీ తెలుసుకోనికి కర్స్ట్ టోపోగ్రఫీ ఫీచర్స్ కానీ గ్లేషియర్ టోపోగ్రఫీ ఫీచర్స్ కానీ తెలుసుకోనికి వాళ్ళకున్న డౌట్స్ని కూడా దీని త్రూ అడుగుతున్నారు సార్. థ్యాంక్ యూ ఫర్ elaborating sir this karst topography and glacial topography. Especially sir summarized that karst actions, how erosion happens and erosional features, how depositions happens and depositional features. Same way in the glacier also, how the glacier actions are there and erosional landforms and depositional landforms, how they are benefit for the world. Also sir explained very well. Thank you sir. And one more doubt sir I have. Karst topography and glacier topography, how is it is useful for the tourism sir?
Excellent. So karst topography and glacial topography. So if you take the karst topography, as we discussed the Porra caves, the naturally formed features, Borra caves in Araku Valley of Andhra Pradesh state. So these are naturally formed features. The people used to visit the area. As the people approaches to visit that, the region becomes as a tourist place. And this tourist place not only generates income to the state or nation, but also provide employment to the facilitators. Thereby maybe the chit chat sellers or chart bandar, or maybe the local articles, or maybe the any other kind of natural products, etc. Whereas the glaciers, when the glaciers are huge in size, when the glaciers are melting and forming as the landforms are the creating the lakes, and the lakes are also becoming as a tourist places. For example, to say we have various lakes in Himalayan rivers. For example, to say Dal Lake in Jammu and Kashmir, right? Nainital, various kinds of lakes are there Uttarakhand, and which are attractive places, the tourist places, and which in earning the foreign income and which attracting the people from the various places.
Thank you sir, thank you very much. అంబేద్కర్ సార్ ఒక చిన్న డౌట్ సార్, ఇది తెలంగాణలో ఎలా డెవలప్ చేస్తారు ఈ టూరిజం విషయంలో? ది కర్స్ట్ టోపోగ్రఫీస్ మైలారంలో ఉన్నాయని చెప్పారు మీరు, వాటిని టూరిజంగా ఎలా డెవలప్ చేయొచ్చు సార్?
తెలంగాణ ప్రాంతానికి వచ్చినట్లయితే మనకు అనేక రకాలైనటువంటి సందర్శించేటువంటి ప్రదేశాలు ఎన్నో ఉన్నాయి. ఇప్పటికీ కూడా ఇక్కడ ఉన్నటువంటి ప్రభుత్వ ప్రత్యేకమైనటువంటి చొరవ తీసుకొని మైలారం ఉన్నటువంటి ప్రదేశంలో అక్కడ ఉన్నటువంటి టెంపుల్స్ ఉన్నాయి. టెంపుల్స్ దగ్గర ఉన్నటువంటి గుహల ప్రాంతాన్ని అభివృద్ధి చెందించి అక్కడ ఉన్నటువంటి ఏవైతే మనకు లభ్యమవుతుందో దాని ద్వారా టూరిజం డిపార్ట్మెంట్కి ఇన్కమ్ వచ్చేటువంటి విధంగా ప్రచారాన్ని తీసుకురాగలగాలి. ఈ ప్రదేశం ఇక్కడ ఎందుకు ప్రసిద్ధి చెందినటువంటిది, ఇక్కడ ఉన్నటువంటి ఆధ్యాత్మిక కేంద్రాలైనటువంటి టెంపుల్స్ ఎందుకు ఎట్లా ఏర్పడ్డాయి, ఆ టెంపుల్ ఏర్పడటానికి కారణాలు చారిత్రక నేపథ్యాన్ని తీసుకొచ్చుకొని అప్పుడు మనం డెవలప్ చేసినట్లయితే ఆ ప్రాంతం డెవలప్ అవుతుంది, టూరిస్టులు ఎక్కువ రావడానికి ఆస్కారం ఉంటుంది, ఇంకా అట్లాంటి గుహలు ఇంకా మనం తెలుసుకోవడానికి కూడా ఆస్కారం ఉంటుంది.
ఓకే, థ్యాంక్ యూ సార్, థ్యాంక్ యూ ఫర్ యువర్ వాల్యుబుల్ సజెషన్స్ on how to develop tourism in karst topography, especially in Mailaram area of Telangana. Thank you sir, thank you very much. With this on this note we are concluding this teleconference, and our learners are enriched and enlightened with this karst topography and glacier topography suggestions and content given by these two resource persons. Thank you very much sir. On this note, I also thank Vice Chancellor Ganta Chakrapani sir for conducting this beautiful teleconference on these topics. I also thankful to in charge HOD Professor S.V. Rajshekar Reddy sir and faculty members of Earth and Department of Earth and Environment Science, Dr. B.R. Ambedkar Open University, Hyderabad. Thank you, sir. Thank you very much.